All right, so this is the first lesson of Pre-Calculus 12, reviewing, hopefully, concepts that sound quite familiar from Foundations in Pre-Calculus 10. And here's kind of a fairly straightforward / annoying example of multiplying with polynomials, expanding, distributing, and collecting like terms. So it says expand and simplify. The expanding part is essentially using the distributive property repeatedly, and I'm going to focus on this part and this part separately. So first, what I've highlighted in blue, x plus 1 times 5x plus 3. I essentially want to distribute the x with both of these terms and distribute the 1 with both of these. Doesn't matter the order. So we tend to call this foiling, although it's not really a real mathematical term, foiling. But going back, first thing I'm going to do, although the order doesn't really matter, as long as I don't lose track of things, x times 5x is 5x squared. X times positive 3 is positive 3x. 1 times 5x is just 1 5x, or 5x. And 1 times 3 is 3. Keep in mind, if there's a positive value, I need to put the plus sign down. Negative, I need to put a minus sign, even though there's so far nothing negative. If I don't put these plus signs down, for example, this doesn't really make sense anymore. It's like a list of things. Or, even worse, or just as bad, I guess, it means multiplication, 5x squared times 3x. But again, hopefully that sounds familiar. All right, that said, let me look at what's highlighted in yellow. I'm going to leave that 3 for a moment and distribute these. 2x times 6x is 12x squared. 2x times negative 2, negative 4x. 4 times 6x, positive 24x. And 4 times negative 2, negative 8. OK, so everything you see highlighted in blue is equivalent. Everything you see highlighted in yellow is equivalent. Now, I'm going to avoid doing too much at once. So I still have this part here, minus 3 times all of this. So I'll put a minus 3 right here. Now, it wouldn't be wrong for me to distribute this negative 3 right now, but I'm not going to. I'm just going to first clean up a little bit, collect some like terms that I'm underlining here. And so on the part that's highlighted in blue, this simplifies down to 5x squared plus 8x plus 3. And what's highlighted in yellow, combine these like terms. Again, negative 4x plus 24x is plus 20x minus 8. All right, now I'm going to distribute the negative 3. I could have done it earlier, but I want to do it now. And so negative 3 times 12x squared, I'll do this one at a time, negative 36x squared. Negative 3 times positive 20x, negative 60x. And negative 3 times negative 8, positive 24. As for what I've highlighted in blue, well, I haven't done anything with it. I don't need those brackets. Those brackets around it are doing nothing. There's nothing being multiplied to it. So I'll just copy this out, 5x squared plus 8x plus 3. And now I'm finally ready to finish this. Like I said, in my opinion, this is not an example of a question that is so much difficult. It's just kind of annoying. There's a lot of little steps. And so it feels difficult if you're rushing through things and making little careless mistakes. But again, individually, it's a whole bunch of tiny little steps. And now all that's left is collecting like terms. So for example, I have a 5x squared here. I have negative 36x squareds here. Put those together. You have negative 31x squareds. Next, I got 8x here, minus 60x. 8x take away 60x is negative 52x. And lastly, plus 3 plus 24 altogether is 27. So this is my final answer. Keep in mind the order of these terms doesn't really matter, but by convention we tend to be kind of conventional, and we put our largest power first and our constant last. So before I move on, keep in mind, like I said, lots of little steps, probably a total of 15 tiny little steps. Most of the steps are as quick as like negative 3 times 12x squared, but there's like 15 steps like that, including collecting like terms. And so showing your work vertically and really carefully is really important. Notice I showed every step on top of the below the previous one. Trying to show your work horizontally, like this step equals this, which equals this, and so on, makes it really easy to lose track of things. All right. So here I have a cube. It's a nice shape, nice and simple. And each side is length x. Oh, come back here. So that means that is x, that is x, that is x. Everything is x because it's a cube. It's all the same. And so this entire cube, if I was to express its volume, remember volume of any sort of simple prism like this is length times width times height. In this case, x times x times x. So altogether, this cube we can call x cubed. That's the volume of this cube, or x to the power of 3. But that's why we tend to say the word cubed for a power of 3, because it relates to the volume of a cube. All right, so now each dimension of the cube, length, width, and height, is increased by 1. So expand and simplify an expression for volume. So that means all of these sides are no longer x. They're all x plus 1. And so the volume of this cube would be x plus 1 times x plus 1 times x plus 1, or x plus 1 to the power of 3. And so there is my expression for the volume of this. It does say expand and simplify. That means I want to first write all this out. So x plus 1 times x plus 1 3 times. And so expanding part is, I'll do, it'll take me a few steps. First I'll go x plus 1 times x plus 1, which again should take 1, 2, 3, 4 steps. And again, each of these steps is not difficult, but just kind of annoying because there's so many of them. That said, it wouldn't be wrong for me to start distributing all this out, but let's clean this up a little bit first. I got two x's here. X plus x is 2x. So I'll make my life a tiny bit easier. And ideally ideally as well, you can remember some shortcuts how to go from here to here, and I'll mention that in a moment. But even then, at this point, now I got to distribute this again. So now I have a few steps. X squared times x is x cubed. X squared times 1 is x squared. And I got to do the same sort of thing with these two terms. And then with these two terms. So it's a matter of just not losing track. So collect all these like terms together. What do I got? I got x cubed. I have a total of 3x squareds. I have a total of 3x, 3 x's, and then just one constant. One last thing I'll quickly say, although I haven't done that question. Like I said, ideally, because this is a grade 11 course, ideally you've learned from Math 10 a slightly faster way to go from here to here. And I'll kind of mention something off this side here. Because really, if I want to go x plus 1 times itself, or if I want to go x plus 1 times x plus 1, I know when I FOIL all this out, I know one of my terms is going to be just x times x, right? Just that times itself, so x squared. I know one of my terms is going to be just 1 times 1, or this times itself. So in this case, just positive 1. However, the middle term is always going to be the same, as in this case, x times 1 2 times. I have x times 1 and 1 times x. And it doesn't matter what terms you have in here. It's x plus 1, x plus 2, 2 minus y, it doesn't matter. The middle term is always going to be the same as this times 2. Because you're always going to go, in this case, x times 1 2 different times. Always. So I can speed this up a bit by skipping this step all entirely. Because like I said, I know that my first term is going to be just x times itself. I know my last term is going to be, in this case, 1 times itself. I know the middle term is going to be 1 times x 2 times. And so 1 times x is 1x, times 2 is 2x. I'm hoping that sounds familiar. If not, well, there you go. But we square binomials like this a lot, and we will do that a lot in this course. And we could speed it up a bit, we should. So one last example like that. Let's say I want whoa, come back here. Let's say I want to do 3x minus 4 all squared without just foiling the whole thing out. So I know the first term is going to be 3x times 3x, which is 9x squared. I know the last term is going to be minus 4 times minus 4, which is positive 16. The middle term is going to be 3x times negative 4, which is negative 12x, 2 times. So times 2. And so negative 12x times 2 is negative 24x. There we go. So with that said, that's what we call, squaring a binomial. And ideally, again, especially in a course like this, we can go from here to here rather quickly. Lastly, what if the original cube, so let me zoom out so you can see that original cube. What if the width is increased by 2, the length is decreased by 1, and the height is unchanged? What's the new volume? Well, in this case, you could be asking, well, which of these is the width, which is the length, which is the height? It doesn't matter. They're all the same. So, the key is, of my 3 sides, the volume is going to be length times width times height. One of them is increased by 2, so x plus 2. One of them is going to be decreased by 1, so x minus 1. And one of them is unchanged. And it doesn't matter what order I write this. Now I want to expand and simplify this. So again, I'm going to choose to do this part first. And so if I FOIL this out, I pretty quickly get x squared plus x minus 2. That's what I get when I combine, multiply it out and combine like terms. So I've skipped a tiny bit of work there just by, I FOILed it all out, 1, 2, 3, 4, and then I combine like terms. And all this is times by x. So now I distribute that x. And we get my final answer, x cubed plus x squared minus 2x. Notice the majority of these questions is just a matter of somewhat routine process where, multiplying, distributing, collecting like terms, all things you've done before. But these are, I struggle to call them skills. They're just like a process. But these are, in my opinion, pretty boring things that are still incredibly important. This is just basic algebraic work that we may be a bit rusty with, but we need to become proficient with this for a course like this, because we will use these sort of processes all the time. And that's where I'm going to be done.